Example 1.43. Suppose a population of fruit flies increase at a rate of g of t equals 2 times e to the 0.02t in flies per day. So t is the number of days. If the initial population of fruit fly is 100 flies, how many flies are in the population after 10 days? So we need to first understand the question. You are given the rate, not the population. So in another word, you don't just plug in t equals 10 and get the answer. We are given the rate, and know that in pre-calculus, we learn the rate times the time will give us the answer that we want. For example, the speed times time gives you the distance. But in our case, our rate of change is not constant. So it's changing with respect to time. So simply doing rate times time, so multiplied by another t, is not going to give us the answer. What we need to do is we need to take the integral. So it's not a pre-calculus concept. This is a calculus concept, and it requires integral to solve the problem. So I will present it a little bit differently from the textbook. So the population, capital G of t will equals the integral of the rate times time, and then you take the derivative. So what we will have is g of t will equals integral of 2 times e to the 0.02 t dt. And then we use u substitution, right? And taking that to be our u, so u will equal 0.02t, du will equal 0.02 dt. And then we can rewrite the integral to be 100 e to the u du. And then we just get 100 e to the 0.02 t plus c, and that's our g of t. And because we are given initially, so g of 0, right? Initial means 0, time 0. We have 100 fly. So we will plug it into this equation, right? So g of 0 equals 100 times e to the 0 power plus c, which is 100 initially. In that case, it implies, make sure you know how to solve this algebraic equation. So c will just equal 0. So now we have our equation. G of t, the population is just 100 times e to the 0.02 t. Then to get what the question is asking for, how many in 10 days? You just plug in 10, so 100 times e to the 0.02 times 10, then you have to use a calculator and you have to run it. You cannot have half of a fly. So just plug it in, take the integer, approximately 122 fly. And that is similar to, it's the same strategy as what we presented in example 1.40. Just a little bit different from what the textbook is presenting. The textbook presented in a way So it say g of 10 is g at 0 plus the change. So net change theorem, right? So what is the change? The change is just, so what is the change? The change is just the change from 0 to 10 of the rate times the time. So that is how the textbook presented, and you should get the same answer.